We're going to start looking at linear equations. So linear equations are equations that whenever you graph them, they're going to result in a line. So we're going to start off looking at key features of linear equations. So key features of linear equations are that they have x and y in separate terms. So what I mean by separate terms is that they're not multiplied together. So if they're multiplied together, something weird happens with the graph, and I'll show you that in a minute. So if you have an equation that has only a y in it, that's also okay. So, or only y. That'll still give you a linear function. So if it's only x, there's something that happens that makes it not a function, but if there's only y, then that's going to be a function. So x and y in separate terms, not multiplied together. Another thing is that there are no exponents on x or y. So exponents make a graph curve, and I'll show you what that looks like. And the third thing is no dividing by variables. So we're going to look at some graphs of these to see what happens whenever we have these things after we go through determining whether something is a linear equation or not. So we can't divide by variables. Dividing by real numbers is okay. So you can have x divided by 4. X divided by 4 is okay. 4 divided by x is not okay. So now let's look at some of these and determine whether we have linear equations or not based on those key features. So the first one we have is 5 minus 2y equals 3x. So if we look through, we have x and y, they're in separate terms, so they're not multiplied together. We don't have any exponents, and we don't have any dividing by variables. So this is a linear equation. If I graph it, I will get a line. The next one is 3 divided by x plus 5 divided by y equals 12. So this is not a linear equation because there's division by variables x and y. So that one's not going to be a linear equation. So now let's go and look at what each one of these looks like. So I'm going to copy this equation. And I'm using a website called Desmos. It's a free graphing calculator. So if I put in this first equation, 5 minus 2y equals 3x, we said this was a linear equation based on the key features. And if we look at the graph that we got, it was a line. So that is a linear equation. Now let's look at the second one. I'm going to have to do a little adjusting after I type it in. All right, so now if we look at this equation, we said that no division by x and y because whenever you divide by x and y, we get a crazy graph that starts to look like this. So another thing we said that we would look at is if x and y were together. So let's just put another equation up here. What if it was like 3xy? So notice that if the variables are multiplied together, you get a graph that's similar to this one when you're dividing by variables. So that makes it not okay. Let's look at another one we said we'd look at. So another thing were exponents. So if we have an exponent, so a regular y equals x is okay. But if we make it x to the second, notice it has a curve. X to the third also has a curve even though it ends in separate places. Then let's just go through some of these. So 4, 5, 6, 7, 8, and 9. You'll notice some similarities and some differences between those exponents, but no matter what the exponent, it's not okay. So even if you had an exponent that was a fraction, it would still make a curve. So notice that x to the 1/2 also makes a curve. It doesn't make a full curve. It ends here at 0. because x to the 1/2 is actually the square root of x. So that would be not a function. And then we talked about if we had just an x equals line or a y equals line. So we said y equals is okay. So if we have y equals 6, notice that's a linear function. It's a horizontal line. So that would pass the vertical line test. It's still a function. But if it was x, we can't call that a linear function. Even though it is a line, notice that it's vertical, so it's not a function. It would not pass the vertical line test. So those are just a few of the reasons of those key features and why they make things lines or not. So when we have a linear equation, we can figure out what the graph of that's going to look like. We can graph that using a table of values. So the first thing we have to do to use a table of values, we want it to look like one of those functions that we've had where you just have one input and then it's going to give you the output. So whenever we're talking about an input, the input is x and the output is y. So we want to get the y by itself. So in this equation, the x and the y are on the same side. I want to get the y by itself so I can put it into the table. So the first thing I'm going to do is I'm going to add x to both sides. So whenever I add x, on the left side I'm left with 1/2 y, and on the right side I'm left with 1 plus x. So those can't combine because they're not like terms. Then the next thing I'm going to have to do is get rid of this multiplication so I can divide by 1/2. But dividing by 1/2, remember whenever you divide by a fraction, you can multiply by its reciprocal. So instead I can multiply both sides by 2. And whenever I multiply one thing, I have to multiply it all. So this 2 times 1/2, that's going to cancel out and give me 1 so that the y is left by itself. On the other side, everything's being multiplied by 2, so that's going to leave me with 2 plus 2x. So we multiplied each side by 2. So once we get this, we have our output by itself, y, and then we're going to plug in an x value to figure out what the coordinate will be so we can graph it. So if we come down, we can look at this table, and whenever we're making a table, we want to choose 5 values of x. So it doesn't matter what you choose. You can choose anything. The easiest numbers to work with are -2, -1, 0, 1, and 2. But here, see that we've chosen 5 different ones. And we're going to plug in these values. So I want to figure out what y is going to equal. And to do that, I'm going to plug in a value for x. So if x is -3, to figure out the value of y, I'm going to do 2 plus 2 times -3, plugging in the -3 where the x was. So if I figure this up, 2 times -3 is -6, and then 2 plus -6 is -4. So that's going to give me a coordinate. The x value was -3 and the y value was -4. So that tells me a point that I can graph. So we're going to continue filling out this table by plugging in these x values and getting more coordinates. So each time we get a coordinate, we're going to graph it. And what we're kind of watching for is that each time I graph a point, I want to make sure that I'm checking and seeing that it's falling on a straight line. So I end up with 5 coordinates. And 8's off my graph, so I'm just going to estimate where it would be. And since it's a linear equation, I can see that it had a y and an x, no exponents, no multiplication of x and y, no division by the variables. And because of that, it's a linear equation. And whenever I graph it, I should get a line. So see how those all fall in a straight line? That's how I can kind of check myself whenever I'm making a table.